Hi, my name's Hannah, and today I'm going to be covering the topic of let it crash in Erlang. Alright, to start off, Erlang was tailored for the telecommunications industry. It was originally made by the cell phone company Ericsson. These cell phone companies had to have a language that could handle millions of users all at the same time. And these cell phone companies also needed their services to always be available. So think about how cell phone users expect to have access to their phone's functions all day, every day. And this is kind of where this idea of let it crash comes into play. It's this idea of handling documented errors while letting others crash gracefully and without affecting other processes. And one of the Erlang's developer describes Erlang is that we're always coding for the happy case. And all of these things I just described are achieved through concurrency, which means that you can run multiple processes and you don't have to run them necessarily all at the same time. So Erlang has three types of exceptions that we're going to go over. A throw is an exception that is used for documented cases, and it doesn't necessarily crash a process and is used more for control flow. An example could be throwing a permission denied exception. So in the documentation for your code, if a user doesn't insert the right password, you would throw this permission denied exception. So in let it crash, this is kind of that happy case we were talking about earlier. So errors are a way to stop a process when you're unsure of how to handle the error. So unlike throw, you don't know the error is not documented. You don't know what to do in this case. And so errors also crash your program, unlike in throw, versus just printing out a message. And errors also print out a whole stack trace. Each error also has something called a reason. So in the example here, it says exception error bad argument. So the reason in this case is going to be bad arg. And in this next slide, you can see all the different reasons that you could possibly have as a result of an error. And finally, we have exits, and for the scope of this assignment, we're just going to treat it the same as an error. The only big difference is the intent behind it. Like, do you need a stack trace, or do you just need a simple way to kill a process? All right, let's get into the examples. Essentially, you can see at the top you have the function talk, which prints out blah blah, and then we initialize 5 different stored functions of type attack. So these are our attacks, and the first one's like a throw, second one's an error, an exit. So we have all the different types of exceptions I just covered. To deal with these exceptions in Erlang, we use a try-catch block. So let's start with the first line. So black knight attack. So this function black knight takes in some kind of attack, which in our case is these sword functions and talk. And then is function essentially just checks if there are any arguments in the function. So this would be our talk function, for instance. So the try tries to find this function with no arguments, and will print out none shall pass in that case. So this underscore catches any type. So if we add other functions other than talk, let's say like move, or you could call it whatever you want, it's going to be caught in this underscore pattern match. In the catch block, on the other hand, we have pattern match for slice, cut arm, and cut leg, and it specifies the type of exception. So slice is going to be a throw, cut arm is an error, and cut leg is an exit. So those specific exceptions are going to be pattern matched to the specific sentences. And this last underscore colon underscore is like a catch-all, so anything else. So for instance, the sword 4 and sword 5 are going to get pattern matched to this last instance and are going to print out just a flesh wound. All right, and here is the output. As we can see in line 9, we call that this talk function. It prints out none shall pass. And then in 10 through 12, we are calling on those on sword 1 through 3, which are those specific exceptions that are caught with their own output. Then 13 and 14 are caught in that catch all and print out just a flesh wound. All right, one last thing I want to cover is the way that Let It Crash handles these exceptions and how they crash is using supervisor trees. So I just want to go over a couple of different ways that this can be done. So the first one is called one for one. So you kill only the process that it crashes. So in this little picture, process 2, it crashes, and then this process 2 is restarted. And that's signified by the red color. A second way is called one for all, so this will kill all the processes regardless of which one crashed and then restart them as well. And finally, we have rest for one, which kills the process that crashes and also all the ones that come after it and then restarts those processes. All right, so this is the end of covering some of the concepts of Let It Crash in Erlang.